In this video we shall be discussing about relationship between radius of the tetrahedral void and radius of atoms in closed packing. Okay, so let us first know how these tetrahedral voids are formed. Okay, so tetrahedral voids are formed in the centers of the four spheres. Okay, so as you can see here, four spheres are there, and in between them a void is present, so that void we call it as tetrahedral void. Okay, so in this particular video we shall be finding out the value of the radius of void. Okay, tetrahedral void. So that one we can find out in relationship with the atoms or the radius of the sphere or particle. Okay, so let us take, let A be the H length of unit cell. Okay, R be the radius of each atom. Okay, and R be the radius of tetrahedral void. Okay, now let us see in right angle triangle ABC. Okay, so in right triangle ABC, by Pythagoras theorem, you kindly write in full. Okay, so we get AC square, or just direct AB square plus BC square. Okay, root over the square I have transferred to the other side. So here what we get, we took the side or the H length of the unit cell as A, so that means the H length is A. Okay, so AB will also be A square plus BC will also be A square. So we get AC is equal to root 2A square, which will be root 2A. This is the value of AC. Okay, so I'll write down here AC is equal to root 2A. Okay, now the next part, again we know that, see, actually these four atoms or particles or spheres are in contact with each other. Okay, therefore the distance between these two atoms will be, suppose A atom and C atom, they are in contact with each other, and we took both of their radius as R, capital R. Okay, so AC will be equals to R plus R. That means the radius of this one plus this one. Okay, this is A, suppose, and this is C. So the distance between them is R plus R, so it will be 2R. Okay, and we also know that AC is this much. Okay, so 2R equals to root 2A, R equals to root 2 by 2A. Okay, so this is the value of R. Okay, so we write it down here, root 2 by 2A. This is the value of R. Okay, now let us take another triangle that is along this triangle ACD. Okay, in triangle ACD we are taking the triangle because along this side, along one of this side, there is presence of tetrahedral void. Okay, there, that's why we are taking that right triangle. So in right triangle ACD by Pythagoras theorem, okay, so AD square, or just AD equals to root over AC square plus CD square, that is AC is this one, root 2A the whole square, plus CD is A square. Okay, therefore it will be, this one will be 2A square plus A square, which will result into 3A square. Okay, and we get AD equals to root 3A. Okay, so this is the value of AD. So AD equals to root 3 A. Okay. Now the next one, okay, that is, suppose you see we know that this distance is root 3a, okay, and also we know that, suppose this is the thing, imagine these are the three atoms present, okay, they're in contact with each other, and this is the part where the void is present, okay. Now as we can see from here that half of this distance, okay, that is r plus r, okay, the radius of this atom plus the radius of this void is equal to half of AD, isn't it? Half of AD if we see along this diagonal, okay. So therefore r plus r equals to, what is AD? AD is root 3 by 2a, okay. Now earlier we got a value of r, okay, that is root 2 by 2a. So what we do is we divide, okay. Suppose this one is equation 2 and this one was equation 1, okay, then what we do is like dividing equation 2 by 1, then we get r plus r divided by r equals to root 3 by 2a divided by root 2 by 2a. So a gets cancelled, 2 gets cancelled, so r plus r equals to root 3, okay, root 3 by root 2 r, okay. Now this one, how we do is r equals to root 3 by root 2 r minus r, okay. So here r equals to, this is 1.732 and here it is 1.414 r minus r. So this one if we solve, then we will get around 0.225 r. So this is a radius, or it says that the radius of the tetrahedral void is 0.225 times of the radius of the atom, okay. So that is the relationship, okay, between the radius of the tetrahedral void and the radius of atoms in closed packing.